Volcanoes stand as some of Earth's most awe-inspiring natural phenomena. Their raw power and majestic presence have captivated humanity for millennia. Yet, beneath their grandeur lies an immense capacity for destruction. These geological giants pose significant threats to human populations and critical infrastructure. They are forces that can reshape landscapes and alter lives in an instant. This inherent danger leads to the designation of certain volcanoes as most dangerous. This label is not given lightly, nor is it based solely on eruptive power. Instead, volcanic danger is determined by a complex interplay of multiple factors. These include proximity to human settlements, the style and frequency of eruptions, and the effectiveness of monitoring systems. Understanding these intricate elements is absolutely crucial for effective risk mitigation. It allows us to anticipate, prepare, and potentially save countless lives. One primary factor in assessing volcanic danger is proximity to densely populated areas. A volcano situated near major cities or agricultural hubs presents an immediate and profound risk. Even if its historical eruptions haven't been exceptionally massive, the sheer number of people and assets at stake can lead to widespread devastation. The impact on human life and economic stability can be catastrophic. Another critical aspect is the specific eruption style of a volcano. Explosive eruptions, often characteristic of stratovolcanoes, are particularly hazardous. These powerful events can generate fast-moving pyroclastic flows. These superheated currents of gas and rock can travel at hundreds of kilometers per hour, incinerating everything in their path. Explosive eruptions also produce widespread ashfall. This ash can disrupt air travel, collapse buildings, and devastate agricultural land, leading to long-term economic and environmental consequences. Furthermore, these eruptions can trigger lahars, which are destructive volcanic mudflows. These torrents of water, ash, and debris can surge down valleys, burying communities and infrastructure far from the volcano itself. The emission of toxic gases, such as sulfur dioxide and carbon dioxide, also poses a severe threat. These gases can cause respiratory issues, acid rain, and even suffocation, impacting both human and animal life. The frequency and predictability of eruptions also contribute significantly to a volcano's danger profile. Volcanoes with frequent, smaller eruptions might be better understood by scientists. This regular activity often allows for more consistent monitoring and the development of timely warning systems. Communities can learn to live with and adapt to these more predictable events. However, volcanoes with long repose periods can lull populations into a false sense of security. Decades or even centuries of dormancy can lead to complacency. When such a volcano finally erupts, the sudden large-scale event can be far more devastating. The lack of recent activity means less data for prediction and less preparedness among the populace. The effectiveness of monitoring systems, while not a direct geological factor, is implied in mitigation efforts. Robust monitoring is essential for understanding and responding to these threats. Let us now turn to specific examples of dangerous volcanoes and the unique threats they pose. These case studies highlight the diverse ways volcanoes can impact human society. Mount Vesuvius in Italy is infamous for burying the ancient Roman cities of Pompeii and Herculaneum. Its history serves as a stark reminder of its destructive potential. Today, Vesuvius remains a grave concern due to its alarming proximity to Naples, a metropolitan area home to over 3 million people. This dense population makes any future eruption a potential humanitarian crisis. Its explosive eruption style, characterized by devastating pyroclastic flows, makes evacuation incredibly challenging. The speed and intensity of these flows demand highly time-sensitive and efficient responses. Sakurajima in Japan is another example of a constantly active and dangerous volcano. It is located perilously close to Kagoshima City. Its frequent smaller eruptions necessitate continuous vigilance and preparedness from local authorities and residents. Life in Kagoshima is lived in constant awareness of the volcano's presence. Mount Rainier in the United States, though currently dormant, is considered highly dangerous. Its massive ice cap presents a unique and severe threat. A significant eruption could melt this ice cap, generating catastrophic lahars. These mudflows would threaten the major urban centers of Seattle and Tacoma, located many miles away. Rainier's location in a tectonically active zone further elevates its risk profile. The potential for a large-scale event, combined with its unique geological features, makes it a top concern. Toba in Indonesia provides an example of a supervolcano. Its last eruption, approximately 74,000 years ago, was one of the largest known volcanic events in Earth's history. This colossal eruption caused a volcanic winter with global implications, drastically altering Earth's climate for years. It highlights the immense, though infrequent, threat posed by such giants. Popocatépetl in Mexico is an active stratovolcano that frequently emits ash and gas. It poses a direct threat to Mexico City, one of the world's largest metropolitan areas. Its ongoing activity requires constant monitoring and preparedness from Mexican authorities. The potential for a larger eruption looms over millions of residents. Nyiragongo in the Democratic Republic of Congo is known for its unusually fluid and fast-moving lava flows. These flows can travel at speeds that make escape incredibly difficult. In recent decades, its eruptions have directly endangered the city of Goma, causing significant destruction and displacement. The unique lava composition makes it particularly hazardous. Globally, many of these dangerous volcanoes are concentrated in specific regions. The most prominent of these is the Ring of Fire. This horseshoe-shaped zone encircles the Pacific Ocean and is a hotspot for intense tectonic activity. It is home to a vast majority of the world's active and dangerous volcanoes. The collision and subduction of tectonic plates in this region fuel the frequent volcanic eruptions. This geological setting creates a continuous cycle of seismic and volcanic activity. Mitigation and preparedness are paramount in managing the risks posed by these powerful natural forces. Advanced scientific tools play a crucial role in these efforts. Sophisticated monitoring technologies are deployed to detect early warning signs of volcanic unrest. These systems provide vital data for forecasting potential eruptions. Seismographs continuously record ground tremors, indicating magma movement beneath the surface. Changes in seismic patterns can signal an impending eruption. GPS, or Global Positioning System, instruments measure ground deformation. Swelling or subsidence of the volcano's flanks can indicate pressure changes from rising magma. Gas sensors analyze the composition and flux of volcanic gases. Changes in gas emissions can be a critical indicator of increased activity and potential eruption. Beyond technological monitoring, community preparedness is equally vital. Developing robust evacuation plans is essential for protecting populations at risk. These plans must be regularly updated, practiced, and communicated effectively to residents. Clear routes and safe zones are critical components. Educating communities about volcanic hazards and safety protocols empowers individuals to make informed decisions. Public awareness campaigns can save lives. Enforcing land use zoning around high-risk areas is also a crucial preventative measure. This prevents new construction in zones most vulnerable to pyroclastic flows, lahars, or lava flows. Ultimately, the most dangerous volcanoes are those where a potent natural force intersects with vulnerable human populations. It is this combination that defines their threat. This intersection demands continuous scientific study to better understand volcanic processes. Ongoing research improves our ability to predict and respond to eruptions. It also demands proactive preparedness from governments, emergency services, and communities themselves. Vigilance and readiness are our best defenses against these formidable natural wonders.